11.2 is on properties of parallel lines, and this is the section where we start solving some problems that involve parallel lines. So every problem that you have isn't trying to see if you know what types of angles they are. What types of angles they are is a section 1 idea. I'm hoping you know which ones are alternate interior, which ones are alternate exterior, which ones are same side interior, which ones are same side exterior. That's what we should have learned in section 1. In section 2, we're going to start solving some problems. But before we solve problems, we need to know about single arrows and double arrows. When we see single arrows or double arrows, it means that the lines are parallel. When you see single arrows or double arrows, it means that the lines are parallel. I'm going to give you an example of the kinds of problems that you're going to see today. I'm going to look at number 3. Number 3 looks like this. It's somewhat complicated, so I'm going to use a little bit of a ruler here to draw this one out. There's an arrow like this. There's an arrow like this. And then there's this other arrow like right about there. Like that. And this is labeled 1. This is labeled 2. This one on the right is 3. This other one is labeled 107 degrees. This is labeled 4. And this is labeled 5. And then there is this single arrow and a single arrow. Just like that. Okay, yeah, okay. You're correct, but that's not where I'm going for right now. Hang on. So, what we're going to have to do, one thing I want to make sure that everybody here understands is this. These little extra arrows, these ones right here, these little black ones that are filled in that are darker. This is a single arrow and a single arrow. What that is telling you is that this line is parallel to this line. And that is important. This line is parallel to this line. When you see those single arrows, you're going to have to know that they're parallel. Because they're parallel, you're going to be able to figure out what all these angles are that are congruent to each other. Okay, so before we even solve number 3's problem, I need you to know that these two little things are the arrows that let you know that they're parallel. Okay, here's the property that we're going to use. I'm going to put the property right here. Property of parallel lines. Let's put it just off to the side. I'm going to highlight 2 parallel lines, and so I'm going to kind of use just a little bit above there and just a little bit above there, below there, right there. And I'm going to go like this, and I'm going to make a line that's a transversal between those two things. Let me scoot this up a little bit. Here's what you need to know. If I know what this angle is right here, if I know that that angle is 45 degrees, and we know that these two lines here are parallel to each other. How do I know? Because there's double arrows and double arrows. Double arrows mean that this is parallel to the other one that has double arrows. Sometimes they're single, sometimes they're double. A lot of times they will use single and double when there are multiple lines that are parallel to each other. The singles are parallel to each other, the doubles are parallel to each other. When two lines are parallel and you have a transversal, this is 45, the top left, and the vertical angle is also 45. Top left, bottom right. What I can do is, if those are 45 and these are parallel, then that means that if I were to slide my fingers down, let me kind of point with these two pins, okay? Top left, bottom right. If I slide down the transversal, then these two angles also have to be the same. It's a property. 45, 45, I slide down the transversal, the bottom right, the top left have to be 45 and 45. So I can automatically put in here 45 degrees, 45 degrees. They are all congruent to each other. Does that make sense to you? That's what you're going to have to apply to all the problems that you have today. So 45, 45, 45, 45. The other ones are supplementary. What does that mean? That means this plus this should add up to 180 degrees. Do you know what 180 minus 45 is, and you know how big this angle has to be? What is 180 minus 45 degrees? Go ahead, Ray.
135 degrees.
135 degrees. These are still supplementary because they add up to be a straight line. And if this is 135, its vertical angle has to be, because vertical angles are always congruent. Bless you. By the way, the same property that we used before, we can use right here. The top right, the bottom left is 135, 135. We could slide down the transversal. Sometimes I make sound effects. Whee! As we slide down here. You remember the slides when you were a little kid, how fun they were? 135, 135, slide down. Top right, bottom left are 135 and 135 degrees as well. Now, that's the property that we're going to be using. So when we go back to number 3 is going to ask the question. It says, name all angles that are congruent to the given angle. Let me write down that somewhere. Name all angles that are congruent to the given angle. Name all angles that are congruent to the given angle. That's what we're going to be asked on number 3. Name all angles that are congruent to the given angle. So that means if this is the only angle that's given, 107 degrees, it's the only one that has a measurement, I can cover this side up, and you should know which angle is the same as 107 degrees. It has something to do with a vertical angle. Do you know which number is going to be the same as 107? Which angle? 2. So I'm going to write down over here, angle 2 is congruent to 107. Is congruent to 107 degrees. Now that's not the only one, because we have parallel lines. And so with parallel lines, you need to think about, here's 107, here's 2, top, right, bottom, left. I can slide down the transversal. Maybe not slide down, maybe slide across the transversal. Do you know See, there's nothing up here where my black pin is pointing, but my red pin is pointing to an angle that's going to be the same. Do you know which other angle is going to be the same? Is congruent to angle 4. That's how you figure it out. Common sense should tell you that the obtuse angle should be the same as the other obtuse angle, and if they're parallel, the other obtuse angle should be obtuse as well. Make sense? That's how you're doing the first 4 problems. Okay? Then we start to get to the harder questions. The harder questions look like number 5, 6, and 7. So I want to show you number 6. 6? Yeah, let's do 6. This is what number 6 looks like. One, 2, 115 degrees. Find the measure of angle 1 and the measure of angle 2. Blank, blank. Oh, you guys can't see that. Let me scoot it up for you. Oh, I'm missing something. Arrow, arrow. You cannot do these problems unless you know something. You have to know if the lines are parallel or not. It only works if they are parallel. So I couldn't do the problem until I put these 2 little arrows there. Once I put those 2 arrows, then you know they are parallel. Then you know you can use the property of parallel lines. Now, with that being said, you're given that this angle here is 115 degrees. It's the top right, which you know that these 2 are going to be the same because they're vertical from each other. The one next to it is supplementary, by the way. It adds to 180, so you could subtract 180 and figure out what it is. And then what you should do is slide. Thank you. We can slide across the transversal. The transversal is the bridge that connects the 2 lines. So I'm going to slide, 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 slide. You should know which angle is 115 degrees. Which one is 115 degrees? Okay, so you can fill that in. Does that mean that angle 1 is 115 degrees? No. It's supplementary. Which means it adds to be a straight line, and straight lines are always 180 degrees. So you're going to have to do a little bit of math, and if this number is kind of big for you, then what you should do is use a calculator.
65.
Somebody else did it for us. I think it was Ray. 65, do we agree with Ray?
Yes.
I agree with Ray as well. So our 2 answers. Angle 1 is 65 degrees. Angle 2 is 115 degrees. Make sense? Pretty simple stuff. You're going to be using this property over and over and over again. But let's get to the harder questions. There is a proof on the worksheet today. I'm going to let you try the proof on your own. I wanted to explore some of the harder questions that you might have or that you might have issues with. I'm going to look at number 10 for sure, and maybe number 13. Will be our last 2 examples. Here's number 10. Number 10 is a trapezoid. single arrow, single arrow, 2x plus 24 degrees x degrees. I'll scoot this up just a little bit for you. It's a question?
Yeah.
What's your question?
Is the answer decimals?
No. Your directions will say find x. Then find the measure of each angle. So those are our directions. Find x, then find the measure of each angle. So when you start getting to trapezoids, this may not look like what we've been doing, but it's exactly the same thing as what we just did with the whole slide down thing that we talked about. Here's your two parallel lines. In every problem that you've been doing, let me go back up. You have parallel lines and then you have a transversal. What they're doing here is they're covering up this and they're covering up that and they're covering up that, and they're only giving you like the C part of what we've been doing. If you don't see it, here's the C that I'm talking about. Here's the C that I'm talking about. So if you need to, what you can do is, if you want to, you can extend this line a little bit, or extend that line if you want to, or extend this line if you want to. I'm going to put little dotted red lines here, because that's what we learned how to do. And in all of these problems in 11.2, you are going to have to decide, when they're parallel, are they congruent or are they supplementary? I'm going to even write that down over here. Your question to yourself is, are they congruent or are they supplementary? Are they congruent or are they supplementary? And that's what you have to decide on all the problems. You're going to apply that question. Hang on, Ray. Well, I know, I don't want the answer. That's what, I don't want the answer.
No, it's not the actual congruent or something.
Okay.
It's supplement.
Do you agree with Ray? Are these two angles supplementary? Okay, so let's take a look. This is what I recommend. If you are looking at this like, what do I do, Mr. Paramo? These two angles, this 2x plus 24 and the top right where I'm pointing at, are the same. They're vertical angles. I had to add that there. And then I could bring that down and bring it right here. And so this red angle that I'm pointing at is 2x plus 24, and so is this black angle, 2x plus 24. And it doesn't matter where you put it. I would probably recommend you put the 2x plus 24 right there, just so that you can see it. Are those the same? No. They're not equal to each other. They're not congruent. So that must mean that they are supplementary. What does that word mean again? It means that this plus this add up to something. What do they add up to? 180. There's your equation. You should write out x plus 2x plus 24. This angle plus this angle adds up to be how many degrees? 180 degrees. Oh, you don't even see that anymore. Let me scoot that over. There we go. So I wrote down x plus 2x plus 24 equals 180, because this plus that should add up to 180 degrees. Let me see if my protractor agrees with me. 180. Yes, it does. Oh, let me use a real protractor. I know I got one around here somewhere. Oops. Real protractor. There we go. From 0 to 180 degrees, right? So now all we do is we do a little bit of algebra. We put 1x together with 2x. They're on the same side. 1x plus 2x is 3x plus 24 equals 180. That's called combining like terms. That's the property I'm using. Just in case that's on a proof. I don't remember if it is. Then I'm going to use the subtraction property of equality, which means I'm going to subtract 24 from 180. 156. I think that's right. And then I'm going to use the division property of equality. I'm going to divide by 3 and divide by 3. 3 goes into 15 5 times. 3 goes into 6 2 times. And now I found what x is. X is 52 degrees. Find x. That's our first answer. Never stop when you find x. You will always, in this unit and in other units, have to find x and then do something with it. Plug it back in. Now I know what this angle is, don't I? This angle is 52 degrees. Is that what this angle is up here? No. Plug it back in. Figure out what this other angle has to be. 2 times 52 plus 24, and this is where I recommend using a calculator. 2 times 52 plus 24. Boom. So I'm just going to write down what I did. 2 times 52 plus 24 is. The other angle is 128 degrees, which are supplementary. They add to 180, so that should make sense to you. Any questions? I feel like I could do some more, but I think that's enough for you to build off of. I'm going to stop your notes right there.